All right. Good morning, gentlemen. I hope you can hear me, right? Anybody
Yes, sir.
there?
Yes, sir. Hello, sir.
Yes, sir.
Good. Can you hear me well?
Yes, sir. Loud and clear.
Yes.
Yeah, because guys, I cannot see your face. That's why you cannot see my face. If you think that I need to show my face, let me know. All right. Because since I cannot see your face, and also actually I don't want to show my face to you, and you can see the full screen. And after all, you're not taking this course for the first time. You know how to study and everything. It's like kind of revision for you. Anyway, guys, I hope you had a good rest for the last how many days? Like 9 days. We didn't have class, so we will continue from where we stopped. As you remember, we were talking about vectors and trying to express everything in terms of vectors. That is what we are doing here in this chapter. And last time we were talking about the not last part 1.3, lines and planes, and we just did these things, how to write the equation of a line in terms of a vector, normal vector, or parametric equations, and also planes in R3, right? Anyway, these are the things what we did in the last class. We stopped here, so we will continue from here. Now we will try to get another thing here, that is the distance from a point to a line, okay? And also here we will make use of vectors. Actually, we will get this formula. Before we prove this formula, let's actually do this example. So it gives us some insight about this formula, and after that we can generalize this case. Okay, in this particular question, it says that, okay, where's my pencil? Wait. Okay, so in this example, it says find the distance from the point B to the line L through the point A equals 3, 4, 1 with direction vector D. Number one is you have to understand the problem, and immediately you have to visualize what is this. And after that, if possible, draw, right, the geometric description of this problem. And after that, we can just use algebra to solve this problem. So as you see here, it says you're talking about a line. Let's say it's a kind of line here, and it is passing through the point A. So it's passing through the point A here. Let's say the point is A here with coordinates 3, 4, 1. With direction vector, so I can put direction vector either here, right, or either here. It doesn't matter. Just actually to understand as well, and maybe just place the direction vector here. This is our direction vector. Okay, it looks a bit weird. Let me just draw this again. This is our direction vector. So that is direction vector D. Okay. And here we have a point. Let's say this somewhere here, point B, whose coordinates are given to -1, 3. So the idea is, so we need to find this distance, right, from B to the line. Actually, that makes it 90 degrees. So we need to find this distance. Okay. So as you see here, if I form a vector using this point, it's given, and this point is given, right? If we just form this vector, let me just change the color. If I make this vector here, right? Let's say this one is vector V. And what is vector V? Vector V is AB, right? And let's see here, this direction vector, and what is this vector? As you know, this vector is then the projection of V, right? Projection of V onto this line. So onto this line, or any vector on this line, that is D, right? So that gives us a projection of V onto the line. That means onto D, it gives us this vector. As see here, this V, right? And plus maybe this plus this equals V. From here, then what is this vector? This vector is, what is it? V minus projection of V onto D, right? So here the question is find the distance from the line to this, to the from the point to the line, means we need to find the distance between the vector V, right? Here we have vector V and this vector. What is it? Projection of V onto the line. That is V minus projection, what is it? Of V onto D. Okay, that means this. In different way we can find this. Since actually we are talking about vectors, I'm trying to express everything in terms of vectors. So that is a question. And as you know, we know how to find the distance between two vectors, right? To do this one, first we need to know vector V. I need to know this thing, right? Then we can just substitute and find its length. Okay, the first step here, in the first step, let's actually determine vector V. What is vector V? Vector V is just vector AB. And we know how to find that, right? That's equal to vector, that's just B, OB minus OA. So here we have OB is, what is it? 2, -1, and 3. Minus vector OA, that is 3, 4, 1. Which is equal to, and just subtracting these two vectors, 2 minus 3, it is -1, -1 minus 4, -5, 3 minus 1, that's equal to 2. That is vector V. So next thing is, okay, now I know vector V. How about the projection of V onto D? And projection of V onto D. And from the last time, if you remember, how do you find this projection of vector V onto vector D? What was it? It's just equal to V dot D over D dot D, right? And these are all scalar, and here we have vector D. Actually, these are all vectors. All right, let me just put a cap here. All right, so immediately let's evaluate what is V dot D. So here, V dot D, that's equal to, what is V? From here, -1, -5, and the 2 dot, and here we have vector D. It is from here, -2, 1, and 3, which is equal to -1, -1, -2, that is 2, -5 times 1, -5, and 2 times 3, that's 6, which is equal to 3, right? In similar way, we can actually evaluate this D dot D, that is just equal to -2 squared, -2 squared, plus 1 squared, plus 3 squared, which is equal to 4 plus 5, it is 9, so that's equal to 14. So this thing, then here we have 3 over 14, and here we have vector D. What is vector D? -2, I mean its components are -2, 1, and 3. I can just write this inside, doesn't matter. So in this way, we identified vector D. So now I need to find, what is it? V minus projection of V onto D. So, okay. I need more space. Okay, so now we need to identify that thing. Number 3, V minus projection of V onto D, right? And what are the coordinates of V? It is -1, -5, 2. -1, -5, and 2. Minus, and how about the coordinates of projection of V onto D? As you know, it is 3 over 14, right? So if I just simplify this, I can just write it as what we have here, minus 3 over 7, because 2 and 14 cancel each other, and 3 over 14, and 3 cancel each other, 1 over 14. So that is minus 3 over minus 3 over 7. Here we have 1 over 14. What is it? 3 over 14 and 1 over 14. So here we have 3 over 14, 1 over 14. Equals, now we can simplify this and get this, the components of this vector. What is minus 1? Minus minus is plus. So that is 7, 3 minus 7, that is minus 4 over 7. Second thing is minus 5 minus 3 over 14. So that is minus 5 and 3 over 14. The last one is 2 minus 1 over 14. It is 28. 28 minus 1, 27. So that is 1 and 13 over 14. So that is the projection of, or is it the difference? V minus projection of V onto D. And actually, we were supposed to find the distance right from point B to the line L. So that means we were trying to find this thing. So now, what is the distance then? The distance between that thing, right? As you know, okay. All right. So here, the distance, number 4, that is equal to, what is it? Distance between the point B and line L. That is just the distance between vector V and the projection of, what is it? The projection of V and D, right? Okay, projection of V, or all right. As here, it should be like this. Why I can't do this? All right, laser eraser. Anyway, I cannot delete to some unknown reason. Here, it should be the distance between this vector V and this vector, right? So we don't have V here. It's just the projection of V onto D, right? Actually, we're talking about this vector, projection of V onto D, and the vector V. And actually, we are talking about this vector's length. So that thing is equal to, what is vector V? Vector V is, anyway, that thing is equal to, what is it? Just the length of V minus projection of V onto D. And we have just found this one, right? That's V minus projection of V onto D is equal to this. So we need to find the length of this vector, minus 4 over 7 minus, let's say this 73 over 14, and this one is 27 over 14, which is equal to square root of, this one is 14. Let me just write here. Here we have 14 squared, and here we have multiplied by 2, 6. So here we have 6 squared. Since squared, we can ignore the sign. Here we have 73 squared and 27 squared. So here we have square root of 14 squared. That's equal to 14. And how about square root of 36 plus 73 squared plus 27 squared, which is equal to something. It's about, all right, plus 27 squared. That's equal to square root of 6,094. Okay. I don't know if we can simplify this or not. It is 6,094 over 14 times 14. That's equal to, okay. Approximately, this thing is approximately equal to 5.58. Anyway, that's the distance between the point and to the line. Now, guys, here, let's just generalize this case. After all, what we have to do here is, as you see in this question, just to find the distance between a point to the line. That means that we need to find the distance between this vector AB and the projection of this vector onto the line. That's just equal to distance between V and projection of V over D. I mean, the onto D. So how about if we apply that thing to this question, and we will get this formula. It says that given that L is in R2, okay, that's a line, and it has two components, and its equation has a general form: ax plus by is equal to c. Prove that distance d from B to L, from B, x sub 0, y sub 0 is given by the formula. So we need to obtain this formula. So, all right, actually the line is in R2. So we are given a kind of line here, and the equation of this line is, what is it? Ax plus by is equal to c. And if you remember, when the equation is given in this form, it is normal, right? That is, it is normal, let's say n. And what are the components of this n? That is just a and b, right? Because a and b and xy, that's equal to just constant number. That we talk, actually we talk about this in the first section of this chapter. All right. So, and we are given a point here, somewhere here. Let's say this one is B, whose coordinates are x sub 0 and y sub 0. Okay, the question is, what is the distance between this point and to the line? So the distance is, what is it? We are talking about that thing from point to the line. So we need to answer this question. All right. How do we answer this question? How do we obtain this formula? To do this one, you see here, let me just form okay. Take any point. Let me just take this point as P. Okay. Since it belongs to this point, and let's say its coordinates are x1 and y1. Since it belongs to the line, it means that satisfies this equation. That means that it's a times x1 plus b times y1 is identically equal to c. Okay. Now from here, using the similar idea, number 1 is form vector v. What is vector v? That is pb. And vector pb, what are the components of pb, since we are actually connecting these 2 points, right? And we try to draw a bit nicely. We're talking about this. That is vector v. Okay. So that is pb. The components will be x sub 0 minus x1, y sub 0 minus y1. That is x. Okay. So these are the components of v. Right. Now from here, okay, I can do like this in another way. What is the distance actually? The distance will be the distance from point B to the line L is the same as, what is it? Just the distance of projection of V, the projection of V onto n, right? Because what is the projection of v onto n? The projection of v onto n will be actually this vector, right? This one is the projection of v onto n. So that thing is, this vector is projection of v onto n. See here, this one is what projection of v onto n. It is parallel to vector n. That means that because n means it's normal to the line, so this angle is 90 degrees. So these two lines are parallel. And also actually the projection will be here, right? So these two vectors are exactly the same, right? So we need to just find the length of this vector. As see here, actually we are just finding the length of this vector. And as remember, what is this? It is just, what is it? The difference of this vector and this vector. So just to find the distance from B to L, we need to find the length of this vector. And if you evaluate this as equal to, what is it? It is V dot N over N dot N. And here we have N, right? Projection of V onto N. Now from here equals V dot N. What is V dot N? V dot N is V dot N equals, what is it? X sub 0 minus x1, y sub 0 minus y1. Dot, how about N? N is A and B, right? So which is equal to A times x sub 0 minus x1 plus B times y sub 0 minus y1. All right, how about N dot N? N dot N is, what is it? Coordinates are A and B, so that's equal to A squared plus B squared, right? And how about here we have N, right? Vector N. So actually I need to put here, okay. Yes, here we are finding the length, right? So I forgot to put this norm symbol. Okay. So here we have, what is it? The length of N. So it's just a scalar, right? And here we have, I can just write it as V dot N, right? I can just take this out, and after that we can evaluate this. Okay. So what we have here? Number one, so we need more space. So V dot N. So V dot N is equal to, as I see here, is equal to A x sub 0, B y sub 0, minus A times x1, minus B times y1. So if you just write this in this form, I can write it as A x sub 0 plus B sub 0 minus, and here we have A times minus x1, B times minus y1. Keep this minus out. So here we have A times x1 plus B times y1. And if you remember this A times x1 plus B times y1, what is it? From here, that's equal to C, right? So A times x1 plus B times y1 equals C, because this x1 and y1 is on the line. So if you just substitute that value, then we will have here A x sub 0 plus B y sub 0 and minus C. Okay. And here we have a kind of scalar, right? And as I say here, it's just a scalar. I can keep this out. And here we have the norm of N. So I can just, here we have something like this, norm, and here we have scalar and vector N. And if you remember, what is it? It's just absolute value of C times norm of N, right? So that means that here we have V dot N over N dot N, and here we have vector N, and their norm that's equal to absolute value of V dot N, absolute value of N, actually N is squared, so we don't have to put this, That is right, just the length of n squared, and here we have the norm of m. And these two things cancel each other. What we have here, absolute value of v dot n over, here we have the norm of m. And that thing we have already calculated, v dot n, that's equal to this, right? So now I can write the formula, the final answer here. Then the distance from a point B to the line L is equal to, what is it? Here we have absolute value of, what is it? V dot m. So absolute value of v dot n is equal to a x sub 0 plus b y sub 0 minus c. And over, we have norm of n. Norm of n is equal to square root of a squared plus b squared. So that is the distance formula from a line, from a point to the line in two-dimensional space. That is what we have to prove, actually. That is the given formula. We just proved this formula. Guys, any question? If you have any question, please don't be shy. Anyway, I cannot see your face. Okay, no question. Let's continue. Another question. Now find the distance from the point to the plane P, whose general equation is this. Okay. How do you evaluate this? We will actually use similar idea. Here we are given a kind of plane. Let's say this is our plane. Okay. And this equation is 2x minus 5y plus 3z is equal to 1. And here we are given a point. Let's say this one is point B, whose coordinates are 2, -3, and 1. Okay, the question is the shortest distance, right? We are talking about this distance. Let's say it is P, and this point is P. So it makes 9 degrees with the plane. Okay, what is this thing? And again, once again, if you just find any point from the plane, right, and the idea is similar, let's say this point is A. So if we actually form a vector that connects these 2 points, and I will get, let's say, A, B, right? Now, we know that here, as you remember, we determined a plane by a normal vector, right? So its normal vector is, let's say it is this. This one is n. And also, if you remember, what are the components of this n? It is just these numbers, right? 2, -5, 3. Because how do we determine plane? It is n dot x is equal to n dot p. These are vectors, right? So from here, the components of n are 2, -5, and 3. So what will be the project of AB onto n? Let's say vector AB, let's denote this by V, that is like vector AB, okay? So then the distance from the points B to the plane P, let's just write like this, it will be equal to, what is it? It is just the length of this vector, right? And that is the same as the projection of, actually it is the distance, projection of AB. AB is vector V, so projection of V onto the normal vector M. And the thing is just we need to evaluate the thing, and we will get, what is this? The distance from the point to the plane. To do this one, we know how to evaluate. This is equal to V dot N over N dot N. And here we have vector N. Actually, all are these vectors. And what is V? Actually, how can I determine this V? I can just take any number on the plane, right? How can I do that? To find any number, I can just choose like this. I can choose, let's say, A, what is A? Any point that satisfies this equation, right? That means that it belongs to this plane. So the easiest one is, for example, here it is 1. So I can just choose it as, let's say, -1 and 0 and 1. If you substitute here, 2 times -1, -2, -5 times 0 is equal to 0. 3 times 1, it is 3. So -2 plus 3 is equal to 1. So it satisfies this equation. That means that this point belongs to the plane. So now, then what is vector V? That is just OB minus OA. OB is 2, -3, 1, minus OA, -1, 0, 1, which is equal to 2 minus 1, it is 3, -3 minus 0, -3, 1 minus 1 is equal to 0. Okay. But actually, any vector that is parallel to this line, it can serve as a normal. So I see here's 3, 3. I can just put star here. I can choose a bit simpler vector. Let's say that V is 1, -1, 0. Also, it's fine. Okay, now, doesn't matter. It's not actually, keep this simple. So now we know vector V. So now we need to evaluate this V dot n. So what is V dot n? V dot n equals, if we have 3 minus 3, 0 dots. And what is n? N is 2, -5, and 3, which is equal to 2 times 3 times 2, that is 6. -3 times -5 plus 15. 0 times 3, it is 0, which is equal to 21. Fine. Okay, guys, here we have norm. And how about n dots n and n dot n? As you see here, it is just, if you simplify this, we will get like this again, because here we have n, right? And because of this norm, and this one n, they cancel each other, because here we have norm n squared. Here we have norm n. So we will have here v dot n over norm of n. So just I need to find norm of n. What is norm of n? Norm of n is equal to square root of 2 squared plus -5 squared plus 3 squared, which is equal to this 4, 25, 29 plus 6, 35. Right? So then the distance will be equal to v dot n, that is 21 over square root of 35. Or if you just multiply by 35, square root of 35, 21, square root of 35. So here we have 35 divided by 7. So it is 3 square root of 35 over 5. And we can evaluate exactly using the calculator. That is the distance between a point and a plane. If you notice here, as you see, the appearance is exactly the same, right? But it's just for a plane. V dot n and n times n dot n. Here we have n. So in the denominator, we have n. So here it says that the distance d from B to P from the point B to the plane whose general equation is this is given by the formula. And so here that thing, that ax sub 0 plus by sub 0 plus c times z 0 minus t, that is n dot v. And here we have the just, what is it? The norm of normal vector. And that is practice for yourself. You'll prove it yourself. Okay. That is the end of this part. Guys, let's have break. Okay. So after 10 minutes, we will continue, maybe 15 minutes. See you in the next session.
Yes, sir. Bye-bye, sir.
Bye.